All right, chapter 7.3, solving equations with multiplication and division. The idea is that if you have two equations and they're both equal or balanced, say we have 4 is equal to 4, if you multiply something to one side and you multiply something to the other side, they're still equal. 4 times 2 is 8, and 4 times 2 is 8. See how they're equal. Now, if we have an x and x happens to be divided by 4, we can multiply, say we have 2. X divided by 4 is equal to 2. This is the same thing. We can do the same exact job. We can multiply by 4 on both sides to see what we can get. Now when you multiply by 4, when you've been dividing by 4, it's sort of like they undo each other. X divided by 4 times 4. So you say we had x is equal to 2. Well, let's say x is equal to 4. 4 divided by 4 times 4. All right, 4 divided by 4 is 1. 1 times 4 is 4. So you just get back to 4. So you had 8 divided by 4, and you wanted to multiply by 4. 8 divided by 4 is 2, and 2 times 4 is 8. So whenever you divide and then multiply by the same number, it gets you right back to what you started with. Start with 8, divide by 4, multiply by 4, and you're back to 8. Basically, that's what we're doing in algebra. Whenever we see something connected to that x, and we're trying to solve for x, we want to find out what x is. And we just do the opposite, or the inverse operation, of whatever's happening. So this is x divided by 4, and we can do it as long as we do it to both sides. It stays the same. We saw that, and it's one of our rules, a key idea, a multiplication property of equality. If we multiply both sides of an equation by the same number, it doesn't change. It is still equal. Okay. So now 4x divided by 4 times 4 just leaves x. And 2 times 4 is 8. And if we go back, 8 divided by 4 is equal to 2. And that's what blue. And we can see that that works. Another thing to remember is that using fractions, we kind of can always use fractions. X over 4 equals 2. Now if I multiply by 4, it's almost like I'm multiplying by 4 ones, and these simplify down to equal 1. 4 over 4 is 1, 1 times 1 on the bottom is 1, 1 times x, it just leaves x. So when I multiply by 4 on this side as well, I get 8. Okay, I know I'm going kind of quick, but I think that's kind of, you need to just see it over and over again, it'll start to make sense. Solve w fourths equals 12. So some number divided by 4 equals 12. So we're just going to come along, we're going to multiply both sides by 12. So they write w fourths times 4. See, we divided by 4, now we're multiplying by 4, equals 12 times 4. And these 4's really do just cancel. It's like divided by 4 times 4. It leaves w by itself, and 12 times 4 is 48. And if we had started with 48 here, 48 divided by 4 does equal 12. We can see that we did it right. Okay, keep going with that. Here's another one. They have x divided by 7 equals 5. X divided by 7 equals 5. So you come along and you rewrite it. You just do the opposite of divided by 7. X divided by 7 times 7, and divided by 7 times 7 just leaves x alone. 5 times 7. Now notice I'm using the dot. It's okay to use the dot. It's okay to use the parenthesis. It's not okay to use the x anymore to stand for multiplication, because we're using an x for a variable and it gets confusing. Okay, so that's why we do that. So x is by itself because x divided by 7 times 7. This is just showing it to you in the non-fraction form. The fraction form is generally the best way to do it, but you can still write a a division sign like this. And 5 times 7 is 35. Then you go back and check your work. So you go back and you put 35 up here. And you just think, well, is 35 divided by 7 equal to 5? And if it's true, then you know you did everything right. That's how that works. The division property of equality is exactly the same, just opposite. So if you have something that's multiplied, like 8 times 4 equals 32, okay, 8 times 4 is equal to 32. If you divide So this is the opposite, the inverse operation. If you divide then 8 times 4 and then divided by 4, it leaves you with that 8. 32, as long as you do it to both sides, you're going to have an answer that matches. Okay? That's what we're trying to see. 8 times 4 divided by 4. If you went ahead and did that on a calculator, that ends up being 8 times 4 is 32 divided by 4, okay, is 8. And 32 divided by 4 is 8. And it just happens. But you're supposed to see that that's what happens. As long as you do it to both sides, the algebra vision looks like this: 4x equals 32, and use the fractional form of division, which I like better. And you just divide by 4 and you divide by 4. This simplifies down to leave you just x. And 32 fourths simplifies down. If you wanted to, you could go 16 halves, which equals 8 ones. X equals 8. So this is the regular math, numerical numbers, and this is using a variable. You still get the same thing. X is equal to 8. And over here, 8 is equal to 8. Here's a couple examples, and then we'll quit, and you can do it on your own. 5b equals 65. Just come over here, grab another color. We're going to divide both sides by 5. I like this method best. 5 and 5 cancel out, and they leave you b. 5 goes into 50 10 times. So it goes into 60 12 times. And it goes into 65 13 times. Or you can get out a calculator if you have to. But I think you can see that. So 5 times 13 is 65. There's a cool one that you just need to understand. The distance formula is something that I want you to memorize. Okay, distance formula. Take a little mental picture of this and just remember it. Distance equals rate times time. And we've already done some problems like this. Distance equals rate times time. If you can just put this in your head. I know I'm asking you to learn lots of formulas, but just keep doing it because they end up being important, and some of them come back over and over again, and this one does, and it applies to various branches of science and math, so you'll need it. It just keeps coming back. They give you a problem. It says Martin Steele set a world record by swimming 5,268 kilometers down the Amazon River at a rate of about 80 kilometers per, and that per is important, per day. 80 per day. So about how many days did it take him? So we're trying to figure out how many days. How many days did it take? And we use our distance formula to help solve this problem. The distance is this number. This is distance. The rate is also the same as the speed. It's the rate, which is the same as the speed. So we're looking here. Hopefully that's not confusing. So this is the rate. And the time is the part that we don't know. It's the rate per day. How many days did it take? Question mark. That's the time. Alright, so we're just going to put in what we know. Distance equals 5,268 equals, because that's d equals RT. So d equals rate times time. We don't know the time, but we know the rate. So 80 times d. See, now we get this, but we don't know the answer, but we do know how to do the algebra. We just learned that if we want to figure out what d is, so we divide both sides by 80. And 80 divided by 80 cancels out, and then you jump on your calculator. If I can find the clear button on my calculator, there it goes. 5,268. If you have a calculator with you, go ahead and do it with me. Divided by 80 is 65.85. So 65.85 equals d. So that's how many days did it take him. So you'd have to say it took him more than 65 days, maybe a little less than 66 days. This is the exact answer. So that worked. All right. You guys enjoy working on this lesson.